Here's the next lecture in our machine learning series. We will talk about data cleaning and preliminary data visualization, as well as splitting of the data. I'm going to use Jupyter Notebook. I won't talk about Jupyter Notebook. I would assume you already know how to use it. And the intent is to later on use Google Colab, which also has a Jupyter Notebook feature in it, so that we can take advantage of the high-speed processing that happens on Google servers. This is why I'm using Jupyter Notebook right now. I'm going to use various books and literature and even freely available courses to make these videos, and I'm going to partially use right now a book called Hands-on Machine Learning with Scikit-learn and TensorFlow. So we will use housing data from California, and we start off with we load the data. So we'll import OS. The CSV file path name is this in red. We normalize the path, and then we check the file name is fine, and then we import Pandas dataframe, because we're going to use that to do most of our work with. We read the CSV file, which is this line. And so another thing I'm going to assume is that you know basic Python, so I will not talk much about that as well. But just by looking at the statements, you can see how a few Python features work. So like if you want to see just a portion or the beginning of your data frame, you can take the data frame.head and it will show you the beginning of it. The housing data has longitude, latitude, and also has median age, the rooms. So it captures data on purchasing of housing in different neighborhoods in California. And in the data, you see we have one categorical feature, which is the last column, right? This is not numeric, so we're going to have to change from these text fields to numeric, because our machine learning needs numeric data to work with. So another command you can easily use to see how your data looks like is dataframe.info, and it shows you the different column names, and it tells you how many non-null fields there are. If you can look at this carefully, you'll see that most of the column names have 20,640 items in each column, but the total bedrooms has 20,433, which means some of its entries are null. So we need to, right, it only has 20,433 non-null entries, which is less than the 20,640. So we need to drop those rows that are null, and we'll drop them for all the columns just to keep things simple. Now you could also look at the end of the data frame using tail. So that shows that. And then now we're going to do some visualization. The quickest thing to do is just do some basic statistic, and you do that with data frame name.describe. What it shows for each of the columns is it shows the number of items in each column, and then it shows the mean, which is the standard deviation, the minimum value, and then the percentiles, 25 percentiles, 50 percentiles, 70 percentiles, right? So, and the max. And 75th percentile means 75% of the values are less than minus 118.01 for the longitude. So another quick way to check the data is to just do a histogram plot. You do hdf.hist, you give the figure size 20 by 20, which is this line right here, and you will see a plot. And this plot will do each of the columns that are numeric. So it does the longitude, the latitude, and then it does the rest of the columns. So what we're going to try to use to do data splitting with would be the median house value. Specifically, if we do a box plot of it, it looks like that. And so the box plot shows the percentiles and the outliers. There's an interesting way you can do scatter plots. We're going to use scatter plots to capture a few things, right? So the way you start is you import matplotlib.pyplot as PLT in this case, the HDF, which is the data frame name, .plot. The plot kind is scatter, X is longitude, Y is latitude, alpha is 0.7. Alpha is transparency of the points on the plot. And we also have figure size, in this case is 10 by 7. And what we're going to do here is we're going to make the color be the median house value, the color of the points on the plot. The color map we're going to use in this case is varieties, and what it's going to do is going to show a color gradient where the various colors depend on the magnitude of the value that is median house value. And we are going to use the size of the data point to be the median income. You come down here now, you take a look at the plot, and you can see the data does look like the map of California. These are the low median house values down here. These are the high median house values up here. And you can see that the high median house values are closer to the coast of California, where the population is also higher and where the median income is also higher, right? And you can tell the median income is also higher because the data point sizes are bigger. Median house value is higher where there is more population and closer to the coast, and median house value is lower where there's less population and further inland. So you could do quite a few things, but and that depends on what you're trying to accomplish. You could take the correlation of certain columns of the data frame. Now, normally we might think, okay, house values depend on total room, population, median house value, and median income. So you could do that correlation and see how they look like. And when you do that, the data frame correlation function, what it does is it correlates each column with the other columns and with itself. So total rooms correlated with itself is obviously 1, but then you can also see, if you come down here, that total rooms correlated with population, there's also a correlation there, and you can also see there's a correlation for median house value and median income, right? And correlation, of course, is 1 is positively correlated, -1 is still correlation but negatively, and 0 is no correlation. And then you can do correlation plots just to see how it looks like. And what we did here was you just plot the columns. You just do a subplot. In this case, we have 4 columns, so we do a 2 by 2 subplot of some size, and then we pass that subplot axis to the data frame plot function, and then we say subplot is true, and it will just plot that. So now we go to data cleaning. The first thing we need to do is remove the null. So we take a look at the data again, the information, and we remember that the total bedrooms had null, so we got to take that out, which we do by data frame function drop NA, and in place is true. In place is true just returns the same data frame as opposed to return a new data frame with the dropped columns. When we do data frame info again, we will see that now all those rows that had nulls in them have dropped, and now we're down to 2433 as the number of rows in each column. And you can take a look at the head again to see how it looks like. Now when you do a drop, the data frame indices have changed now, right? So you got to reset the indices, and this is what we do here. So HDF reset index, right? Drop is true, meaning we don't want the index to be the old index to be part of the data frame. In place is true, meaning we don't want a different copy of a data frame sent to us. And then now we are going to take a look at what the categorical column, the text field column is that we had in the data frame. So you do that, we are assigning it to some variable. We're going to go categorical calls. So the data frame name, we select the data type, D types data type, and we only want to include the type object. Type object would be the categorical data types in the data frame, or think of it as the non-numeric data types of the data frame. So Python object type. So now we look at the categorical columns head. You can see that we just got the column with the text values, and so now we get the column names, and the column names is categorical column dot columns, and we turn into a list, and we just had one categorical column. So when you print the column name, it shows the column was ocean proximity. So the next step at this point is to convert the text field of that categorical column into numeric set of fields. And the way it does that, you can do that in a few ways. In this way, we're going to use the pandas function called getDummies, and what it essentially does is it's going to take the categorical fields and turn them into a binary data set as shown below. So the encoding, which is essentially the conversion, is you use this function, you pass the data frame, and then you give the categorical column name, and it's going to do the conversion. You take a look at the head, and and what it does is it keeps the previous numerical data of the other columns that were in the data frame, and then it's going to add new columns. And the columns it add is it takes that categorical column name, ocean proximity, and takes one of its fields and one of its values, and then it creates a column with it. Takes the same column name, another value, creates another column, and just like that with all the values of that categorical column. So you can see, you can have a situation where if you have a lot of different text values in that categorical column, or if you have a lot of categorical columns, you would end up with a lot of encoded columns with zeros and ones. So now what it does is it creates binary digits here. It gives a 0, a 1, and a 0 for the first row, right? And if you notice, for each row there's a bunch of zeros, and then only one column has a 1, right? And it does like that all the way down. And I'll explain using the Scikit-learn process how that happened. So the Scikit-learn process is called one-hot encoding, which just means for each row only one value is a 1, the rest are zeros, which is why it's called one-hot encoder. And so for Scikit-learn, you do Scikit-learn pre-processing import one hot encoder is just going to create the same thing that getDummies did, except when it creates it, it's not going to put it in the data frame immediately. This is why I like to use the getDummies version. We do the import. We initialize the encoder. Sparse equals false means we want it to show all the zeros and ones. As I explained a little earlier, you can see that if you have a lot of categorical fields, you will end up with a lot of columns of zeros and ones. And so Scikit-learn has this feature where it can help reduce the output of those columns if you set sparse equals true. Now, I'm happy to receive any comment or input from anybody who has another view on this. Right? Any input or any comment, please leave a comment below so that we can create a great learning forum here. Okay, so the next thing now is we do the encoding, and the way you do the encoding is you just use the scikit-1 hot encoder fit transform function, and you pass the data frame columns that have text values. So it's the data frame, and then you pass the categorical column names, and the categorical column names needs to be a list. And then if we output what it looks like now, you can also see it's 0001, 0001. So every row only has one in it. The rest of them are zeros, right? The next one, this one, the ones are here, and the rest of the rows are zeros. And so if we want to compare this now with the initial categorical column that we did this encoding with, you can do that in a few ways. So the output of the scikit-learn encoder is an array. So we convert it to a data frame, and you convert something to a data frame, you pass the array, and then you pass the column names. So this is what this function does. It essentially just passes these column names up here. Right, and so now we have a data frame, which if we look at the head, you can see that it's just created a data frame of this data. This is what we have here right now. All right, if we now include the original categorical column to this data frame, just so you can see how the encoding works, we insert into it at the first column position. So you do data frame name, insert at location with the first column, and then you give it a column name ocean proximity, which was our original column name, and then value you take from the original data frame, you take out that column. And so now we take a look at how it looks. So now you can see that where we have the value nearby, okay, that's where we have a 1. Okay, so let me see if I can zoom a little. You might not see very well, but the idea is pretty clear, right? So whenever there's a nearby, we have a 1, and that 1 is under ocean proximity nearby. Wherever there's a nearby, you have a 1, right? These are all nearbys. Okay, and then when you go to inland, you now go to the ocean proximity inland column, and then you have a 1, and then the rest of them are zeros. So that's how the encoding works. It takes the categorical value of the column we started with, and then it creates a new column and puts 1 there for wherever those values were supposed to be. And for all the other categorical values of the original column we started with, it's going to also create new columns, and it's going to put zeros there because the value at that position was for nearby and not for all the other categorical values. When we go to a new categorical value, it does the same process. It puts 1s at its column and then puts zeros everywhere else. I hope that makes sense. That's how that works. back to our get dummy. We do the data splitting, which is the next feature here. For machine learning, we need what is called a label or a target column. And in this target column, I said earlier, we're going to use median house value. So I'm going to separate the median house value from the rest of the columns in our encoded data frame. And so what I do now is I drop the median house values from the rest of the columns of the data frame, and you do axis equals 1 because you're trying to drop a column. If it was axis equals 0, which is the default, you'll be dropping a row. And so what I will have now, XDF, would be there will be no median house value column. And so now when you come down here, you also extract the median house value from the encoded data frame, so that we can have a Y label, which is the median house value, and then we can have an XDF that is everything but the median house value. And so now we do a data split. For random data split, you do from Scikit-learn, model selection, import, train, test, split. This is what it's going to do our splitting. And then we split into a training data and a test data. It's going to do this X data, which is the input to a neural network, and then X test is what we're going to use to test the network with. Y train data is the label or the target output of our network, and then Y test data is also the label that we're going to use to do the testing with. They're going to be a whole different series on how neural network works, how artificial intelligence works, and so I'm not going to spend a lot of time on that in this section. All you got to remember is that to get the network to do what you want, you need to train it, and so you need data to use for training, and you need data to use to test how good your training was, right? And this is what we're doing here. We're trying to split our data so that we can use some of it for training and some of it for testing. Now, you use a lot more data for training than you use for testing, right? Because the training is what gets the network to be able to work. So in this case, what we do is we train, test, split. This is the XDF, which was the X data, the Y label, which is the Y label up here, and then we say test size. We only want, since most of the data we're going to use is for training, we only take 20% of the data to use for testing. So 0.2 is 20%. Random state equals 42. Well, 42 is just an integer. It could be 1, it could be any integer. And the idea of using 42 is so that if we want to pass this, if we want to repeat this training again and pass the 42, it will produce the same X train, X test, Y train, Y test. So here's our X train data, and you can look at X train info. It splits it into 16346 number of rows, and then there's a X test info. It splits it into 4087, and obviously if you added 4087 and 16346, you should get back the original number of rows you started off with. And same thing for Y train and Y test data. And there's another method of splitting that other people use, because they say the random process of random split might not proportionally select values. Okay, so we're going to use another method that Scikit-learn uses, and in this case it's stratified. Think of it as strata. You can think of it as groups, and then you randomly select from each group in proportion to the number of samples in the group. And so what we're going to do here is do something first, which is going to fail. We're just going to import from Scikit-learn model selection stratified shuffle split, which the stratified part is creating the strata, and then the shuffle would be like random selection from each of the stratum that we have. And so you split again, which is the initialization. We just want one split. Test size again is 0.2, and then random state is 42. So same reason for the integer number there. We initialize the splitting up here, and then now we retrieve the indices of that split. And the way you retrieve the indices of the split is you take this split up here, which is just an object returned by the stratified shuffle split, and then you use a function that is part of the stratified shuffle split, and the function is called split. And in it you pass the data frame that we want to do the splitting and the label. So this function returns a train index and a test index, and it returns them as a list, right? So what you now do now is you go to your data frame and you retrieve those train indices, and that's how you do that, right? You just pass the list of indices, and then you do a lock function and you retrieve that, and then you repeat for the next one. And we have an error here. Why do we have an error? We have an error because down here it says the least populated class in Y, the least populated group, only has one member. Okay, so then it doesn't run properly. So what we then do now is you could do different things, right? I just do something simple. I take the median house value again, which was our Y label, and I do a describe on it. It's going to give me the few statistical parameters, one of which is the standard deviation, and then I'm going to divide that median house value by the standard deviation so that I can form groups out of it, so that way we don't have only one member in any group, right? And so when I do that, I just import numpy and I create a new data frame column, and I do the median house value, which is column, which is this one, and then I divide it by the standard deviation, right? So I created a dictionary up here by key value, key value, key value. So the dictionary value of standard deviation is this 115435, so it's right here. So I divide everything, and then I take the ceiling, which essentially groups the data now. And so for instance, if it was 1.5, the value will be 2. 1.7, the value will be 2. So you can now see that a row that had 1.5 in it and a row that had 1.7 would be in the same group because the ceiling has made the value 2 for both of them. So that's the idea. And then if I take a histogram now to take a look at what this does, you can see that I've created different groups. So what I'm going to do now is repeat the same process up here with the shuffle split, but this time I use the median house groups. I'm very much interested in your comments on this so that we can all learn. So please, if you have any other input on this one, please leave a comment below. And then when I look at the split by looking at the train data, the head, you can see there was no error this time in the splitting. You can look at the train set head and you can see this data. And then since we use the median house group just to do the grouping to help with our splitting, we don't need it anymore, right? So we drop it. So these lines drops the one from our train set, and then this line drops the one from our test set. And you do by drop as before. You say the data frame, the function drop, and then the column you want to drop in place. So you want to keep the same data frame but without this column anymore, and then you drop a column as opposed to a row. And if I take a look at it now, you can see that there is no med house groups, right? It has longitude, latitude, you go all the way down, there's no med house groups. And then if I look at test set, the number of items now is 16,346, 40, 87 as before. And you can look at the the test set head, it looks like that. What I'm doing now are just examples of how you do things, right? So now you could also do a histogram plot and see how your medium house split now looks. And it looks like that. It doesn't look too different from random data split, but depending on the data, it might be different. This is the shuffle split data, and this is the random data split data down here, and they don't look that different, but that I was just showing you the different ways you can do this. So the summary so far is that you load the data and then you do a preliminary data visualization. Sorry, this is supposed to say data up here, which you can do with a histogram plot, a box plot, scatter plot, correlation plot, whatever it is you want to do. It describe to show the statistics, and then you do data cleaning, which might be, in this case, remove the nulls. And then after you do data cleaning, you do your encoding as well, so that you can replace categorical columns with binary numerical equivalent. You then split your data, which you can do with what probably a lot of people do. You just do a random train set split, or you can do a more involved shuffle split, depending on what you're trying to accomplish. And this is the shuffle split right here. So that is the step towards our machine learning process that I want to show today. And the next part, of course, would be an even more fun part, is how we use this data along with TensorFlow to do machine learning work with. Thanks for watching. Please subscribe, please comment. I'm really interested in getting your input. Share the video. Have a great day. Bye.